Good morning, good afternoon, good evening, good night from wherever you're tuning in. I'm really glad for all of you who have been able to join us today for our AI Guild session. I could not be excited more to introduce Sachin. Sachin is a senior machine learning engineer in Canva. He is in Sydney right now. So thank you so much, Sachin, for joining us on a Saturday. He has a Ph.D. in Bayesian Machine Learning, so he's been doing a lot of work, a lot of really cool stuff around machine learning and around NLP especially. So today he'll be talking to us about multilingual clip using Hugging Face and PyTorch Lightning. And apart from work, he's been doing a lot of different stuff around like preparing courses on Udemy. So I would be putting out all those links about the research and the courses that he's been working on the description below. So you can check that out later. Thank you so much for being with us, Sachin. I'm really glad to have you here, and to be honest, cannot wait for you to start the session. I've heard you talking about multilingual clip before, and it's very exciting. I'm very passionate about like learning more about NLP because it's a very vast field, and there's so many things that still needs to be explored. So I'm super excited to hear you.
Thank you. Thank you. So thanks for having me, first of all. And so I think what I might do is I'm going to share my blog instead of sharing slides, but I'm going to be doing it is because that was a Jupyter notebook that I had. And so I'll let me just get started with that and just take it away. And by the way, I think I might get you to ask me rather than wait to the end because I feel it's I don't want people to.
I will be having the questions through the chat. So I'm observing all the questions. So as and when they come in, so I will let you know.
Yep. All right. Can you see my screen?
Yep.
Okay. All right. Perfect. So Clip. Just to give you some context, Clip is this model that OpenAI came up with a few months back. And the main idea was so that they can match up images to text. At the exact same time, I came out with a different paper called DALI, which is actually doing slightly different idea where they're given a piece of text that is generating images. So we're not going to be talking about that today, but I'll be referencing that at the very end. And and this image is going to be crucial, but right now let's just ignore that. I'm going to be doing two passes over this Clip model. The very first time it's going to be somewhat high level, mostly focusing on just the model in itself and the loss function. The second time I come around, I'll probably start talking about the nitty-gritty things about PyTorch Lightning, specific things about even Huggingface that I found interesting. So yeah. Okay, so the first thing, the data set. The data set is called a Cocoa data set, and you can download it yourself. But what I found lately is that it's actually easy to get on Kaggle. So for me personally, it took about 10 minutes for me to download it and unzip and all that. But if you go on Kaggle, you can find it straight away. So, and I'll speak about to that right at the end. But just to give you an example about the kind of images that you have, it's something like this, right? So you get an image and a matching piece of text, but they have 5 pieces of text. So in this case, it's saying a lone zebra grazing in some grass. What I've done is out of the 5, randomly pick out one. So with the epoch or the batch, for each image, we're going to be looking at just a single piece of text. Main idea, again, is to try and match up images to text, right? So think of this as a search algorithm, right? So how do I match text and images without looking at keywords and stuff like that? All right. Again, I'm going to be skipping through the nitty-gritty stuff, which I'll come back to. But yeah, so that's the main idea about the data. The model. Okay, so this is really the interesting thing. Now, usually when I've played around with models, any kind of model, it's always been only a vision kind of thing or only a text-based thing, never anything combined. So this was quite exciting for me to be able to combine both vision and text together, right? And the best thing about this was that it was super simple thing to do. So all we're doing, if you're already aware of transfer learning, you're halfway there. So all we're going to be doing is we're going to be choosing a base and choose any base, right? It doesn't have to be the same thing that I've chosen. So I managed to choose Resonant and put a simple projection layer on top. And same with the language model, I chose a BERT model, or a distal BERT model to be exact, and they put a single projection layer on top. Okay. Now, if you don't know PyTorch, it really doesn't matter. You can do this in Keras as well. In fact, like I copied most of the code from a Keras tutorial and converted PyTorch. But all it's doing is I have two dense layers if you're coming from Keras, putting them on top, and then just passing in the output of the base. Right. So if you look at this thing over here, this is all I'm pretty much doing. Right. So taking the base and then passing it to projection. But the additional little detail is that I'm setting all the base parameters to be not trainable. Right. So I'm not going to train any of the base parameters. So it actually makes it easy to train this thing. I managed to train this within about an hour. So yeah, and the vision encoder and text encoder looks pretty much the same. So the only difference is it was slightly easier with the vision one because I just had to do self-dot base and projection. With the text encoder, I needed to take the CLS token, but let me come back to that because that's being very specific. Okay, so point is I just needed a base and put a layer on top. Okay, so that's the first important thing that we just covered. If there's any questions right now about anything we covered? No? Okay.
No, right. There are no questions right now.
Sure. Okay, let me keep going there. So the loss function. Now this loss function is probably the most interesting part of the entire paper or blog post. So usually we only look at, say, cross entropy loss or like mean squared error kind of thing. What's interesting about this one is that it's still cross entropy loss, but on a slightly bigger scale. So let me go back to the first image that we talked about. Okay, so I mentioned in that what we're trying to do is that we're trying to match up images to text, right? So what we're going to be doing is we're going to be taking the image encoding and the text encoding. We're going to take the dot product, and we end up with this matrix over here. Now, we know that it's each image in a batch will correspond to the text, right? So it's really the diagonal that we want to maximize. Everything else we want to minimize. So the loss that they've done is simply take cross entropy loss across the row, but at the same time keep in mind you can also do the cross entropy loss in the column as well. So that was quite a new idea, right? So usually you just take it row by row and you're done. But the reason that you can take it by columns as well this time is because, well, it doesn't matter which way you're matching it, right? So text to image or image to text, you still want to maximize the diagonal, right? So they've done both, and it's the loss is just simply the sum of that. And that's really all there is to the loss. And that is exactly what I've done over here. Okay, so I'll call this a contrasted loss. Now, yeah, so I'm taking the log softmax and taking all the diagonal elements. Okay, so this is exactly the same as cross entropy loss, except on a batch scale. And yeah, so, and then I average out the two. And then I've done some metrics, which is just simply accuracy. Okay, that's really most of it. The rest of it is, well, the rest of it is PyTorch Lightning, which is where we get into a bit more specifics. But yeah, this in itself was fairly simple thanks to PyTorch Lightning when I was training. So all I had to do was send in the vision encoder and the text encoder in my init. And then I take the image embeddings and the caption embedding per batch, look at the similarity. So it's the similarity so similarity is simply the dot product of the captions and the images. And then I take the loss. So these 4 steps is my training. Look at the accuracy, but that's an extra detail that you don't have to worry about. And finally, so with the optimizer, one thing that I had to do the way that PyTorch Lightning is structured, I needed to pass into Atom both the vision parameters and caption parameters together at the same time. So the first time I tried to do this, I sent in 2, like I had the the vision parameters inside the array. And for some, well, it didn't work because it was looking at this optimizer index. But yeah, so that's if you're aware, if you're already playing around with PyTorch Lightning, just be careful to put that in.
Sachin, a quick question. I think we have a question from Abhishek. Let me just put that on the screen. So he's asking about the base encoder, which you're passing for the image image encoding part, and what does it like do basically?
What encoder doing?
Yeah.
Was it the question? Right. So was the base encoder, which is okay. So okay. So this comes back to transfer learning, right? So so have you ever done a tutorial on image classification? Generally, what you do is you don't try and train the entire image classification by itself. You can, if it's something simple like a binary classification, but if you're talking about multiple classes, like say in the tens or hundreds, generally what you do is you choose a base layer being pre-trained on different tasks. For example, ImageNet is this huge competition where people try to classify into 1,000 classes, and it's already been pre-trained into that. Into 1,000. So what you can do is you can take that model from a completely different domain and transfer it into here, right? So that becomes your base, and all you need to do is you need to put in extra layers to match to your specific task and take it away from there. So that's the image case. In the case of text, there is BERT, right? So BERT, there wasn't 1,000 classes. What they've done is they've trained on Wikipedia corpus, trying to predict, say, the next word, or they've tried to train it on sentiment. They've actually trained on multiple tasks for BERT, but the point is they trained it on this massive data set to do something, and it learns the structure of sentences or language. So you can transfer that knowledge onto language models, any other language problem, and that is what I've done over here. Does that, hopefully that answers your question?
Yeah, thank you.
Yeah. All right. So yeah, and lastly, the training bit, the actual training bit, which I find amazing what PyTorch Lightning have done. So all you need to do, so you need to specify the model, but otherwise all you need to do is you need to say what the epochs are. You can do things like gradient clipping with it, which is just a single argument. So gradient clip is 1. 16 precision is there. Lately, I've actually started using weights and biases as a logger, and that's been just another argument. So that's been pretty amazing just to be able to do that. I didn't manage to get TPU unfortunately working, but I'm not entirely sure if that's a Colab issue or PyTorch Lightning issue. So I'm still working that out. But yeah, so the last time I tried it was on TPU, which is why you can see the error here. So let's just ignore that. But yeah, so in this case, I logged it to TensorBoard. Well, I didn't log it. It logs to TensorBoard by default. And all you need to do to get TensorBoard is just run these 2 lines. And yeah, you can see the training loss decreasing and yeah, the accuracy increasing. So that's it about the training. And finally, just the results, just to show you some of the results that I got. The first bit of what I've done is I looked at a random sentence from the entire corpus of text that I have, and see what are the closest images from the Coco dataset. Okay, so we are dealing with a limited dataset, but I just want to see what we get. So the first sentence was a baseball player in the outfield with his hands up, and you get this one. So it's probably not with his hands up, but you still get a baseball player, which is pretty amazing. So all of this is pretty, yeah, all of these images are baseball. And keep in mind, there wasn't anything in the data set that had this class saying this is baseball and this is, yeah. So that's the best thing about it, that you don't need to specify. And here's another one, a watch and a clock repair shop window with clocks on display. So the first one it probably doesn't quite match it, but the last one does have the clocks in there, right? So the similarity score that the algorithm's given is 91%. So obviously it's not perfect, but also keep in mind, I only trained this for one hour. I chose one of the smallest image models and one of the smallest text models. So it's this, like if I probably training for longer with bigger models, I probably could have gotten much better accuracy. The third one,
One question I have here, Sachin, like we typically talk about like not just about the training parameters, but also like training time and the hyperparameters that we use for the models. So what is your approach in finding the best set of parameters for all of this? Like not just the hyperparameter, but also the parameters in terms of, okay, how many images should I use? What should I set as a good training time? So how do you like have an estimate of all these parameters when you're building an image model?
See, like that's one thing I actually still struggle with today, right? So choosing those parameters that just works. So a few days ago, I was trying to implement this different paper about it's called Dino. Basically, it's trying to do self-supervised learning, but it was really hard to implement because they had very specific parameters in the paper, and even though I tried to match them as much as I could, it still didn't give me a good result within a reasonable amount of time. So so let me just say that with this paper, the reason I find this a really good paper is because I don't think it's that sensitive to hyperparameters. So I chose one of the weakest models and still got a good result, which means it's a fairly strong paper in my opinion. If you are to go down that path of trying to find the best parameters, I know that Weights and Biases has a high parameter tuning service, and there's what's the latest? Optuna, if you ever use that, is a really good open source library for hyperparameter tuning. So there are libraries that you can choose, but I personally, well, the first try at least, I tried to use it by using reasonable things. Like for example, learning rate in this case, learning rate I chose 10 to the minus 3. There was no reason I chose that.
I have the same thing as well. Like I've never really understood like a deterministic way of understanding what should be the hyperparameters or what should be the training time, etc. So I thought maybe there is somebody else who doesn't have the same problem as me. So yeah, same for me. Like I never am able to have like a deterministic view on, okay, this is the right kind of parameters because of these reasons. So yeah, I have the same thing. Also, like there's an interesting question that Shreya had posted. So she's asking, is the model pre-trained for non-English languages for the text part as well?
Yeah, that's a very good question. So the language is pre-trained, but in this data set, there is everything in here is non-English. So let me get to a result that is non-English. So the English sentence was zebra standing up with his head down, and I just used Google Translate to translate it to Spanish. So that's the thing. And yeah, here we go. We got a zebra in there, right? So but in the training set, it did not see a single non-English sentence, which is quite amazing. And the reason I was able to do that is because BERT, well, thanks to Hugging Face, they had pre-trained it for non-English, and I was able to put in any kind of language. So I think I tried for a few others. So in this case, a laptop is displayed, and to French. So you can see a laptop in the thing. So again, nothing. It didn't work so well with Russian. A shop filled with different clocks. Yeah. No, I suppose it did. There's a clock image in. Oh, sorry, this is the actual image. But yeah, so it did not actually work for Russian. But the point is, no, I did not train it, but it was pre-trained for non-English.
Oh, got it. So great, yeah, you can continue with your flow.
Yep. Okay. So and so the last thing that I checked was does it work well with single words, and that was quite surprising to see that it did, right? So generally, like usually, one of the quick ways of doing this kind of task is just to take the word embeddings and see if they try and match up to images. But it was strong enough to it was able to still pick up on a single word as well, which I was quite surprised about. Okay. So second pass. So this time, let me dive a bit more into detail with some of the PyTorch Lightning specific stuff that I found interesting. In fact, I might actually switch to my Kaggle kernel when I do it. So, okay. So the reason I chose Kaggle kernel is because the data is attached. So the Cocoa data set is already there, and I did not need to download. So that was one pretty amazing. So the specifics, the main things are like the transforms, right? So that I chose a 128 by 128 image. Sorry, I resized it to 128 by 128 just so I can keep up a reasonable amount of training time. But I think one thing that most people tend to miss on is the normalizing bit. So usually they just divide by 255 just to make the values between 0 and 1, because 255 is the maximum pixel value. But it's important to normalize it so that it's the same mean and standard deviation as initial. At least that's my opinion. So that's the numbers that you see over here. So that's the first point. I guess, yeah. Oh, the tokenizer. That's a fairly important thing. So the tokenizer is, again, coming from Hugging Face, is a BERT tokenizer. But what you need to do, remember that when you send in a batch, everything needs to be of same size. So what a tokenizer does is that it takes sentences and converts them into numbers. In this case, it's like, for example, the might have the number 1, 2, and so on, right? So this is doing it for you. But because of different sentence lengths, what you need to do is you need to make sure that they are truncated, right? So they need to have a maximum length. But if all the sentences, so in this case I chose a maximum length of 64, if all the sentences are much less than 64, there's no point allocating the extra space. So luckily, the Hugging Face tokenizer does that for you, so that it only passes it up to the maximum length, right? So fairly smart in that sense.
Got it. Sachin, there's a follow-up question that Shreya has put up. So she's asking if you're using mbert rather than BERT in this particular case.
I'm using DistilBERT actually, so I haven't used
Okay.
mbert. Yeah, so yeah, it's just a DistilBERT, but with the multilingual in there. So yeah. What else is important? Let's see. This is standard training validation split that I've done. The projection layer, if anyone's concerned about the specifics, all I've done is I've actually put 2 linear layers in, only because that's what the paper suggested. But I did specify the bias to be false, because the reason I think it's important is because by saying bias is false, what you're doing is you're effectively rotating the embedding that comes out of your face. If you set the bias to be true, you're rotating and then you're pushing it out as well. So all I wanted to do was rotate my thing. So that's why I set the bias to be false. It was also important to make sure that the base was did not train, because otherwise I don't think I would have been able to train in a reasonable amount of time. I think if you unset this, you might actually get better results than I do. But again, I got good enough results without needing to do that. So it's questionable if I need to or not. Yeah, I think that that's pretty much it when it comes to the actual implementation. There are some extra stuff that I've done with weights and biases over here, like logging the histogram, which I didn't quite manage to get it working on time just before this. But yeah, look, I think we've covered the main aspects of CLIP. If there are any questions, I'm happy to take them.
We currently don't seem to have any other questions around that. But
Okay.
if you have any suggestions around, the use cases that could be similar, like, where you could be using similar models, and some of the things that people can actually practice otherwise using like a multilingual clip.
So in terms of use cases, first of all, like I think if you're working for a company that needs to do image search, this is a very powerful algorithm, and it is available for free on Hugging Face, right? So you don't need to train anything; you can just download Hugging Face straight away, and it's available for you. But in terms of like training this stuff, you can always follow my tutorial. Like one thing that I tend to do these days is just try and read up Kaggle kernels these days, and that tends to help me figure out bits and pieces of this stuff. Was that Was that the second
Yeah.
part of the question? Yeah. Okay.
So another thing, like if you can, I know that you've been putting out a course on Udemy, right? So could you probably talk a little bit about that as well, so that people can check that out if it's something of their interest.
Sure. Thank you. Yeah, so I've made a Udemy course starting. Well, it was mainly towards the beginner to intermediate kind of people. So we go through how do we build random forest from scratch? How do we build so just starting deep learning from scratch, gradient descent to classification. The latest thing that I did was to classify 100 birds in images. I haven't gone as far as doing clip there, but I feel like once you get to that level, you really need to be reading up blogs, reading up books. It's such a wide field. This deep learning, it's touching every single field. It's really hard to make an advanced course and to cover a lot of things. So anyway, that's as far as I've gotten in the course.
So I'll share all the links that you have, Sachin, like with respect to the blog, with respect to your course, and if you have any other resources to point out for the people, like to share all those with me. So I'll just put that in the description of the video below, and they can check this out later. As a follow-up, I think Shreya had another question. So she was asking for the image part if you've used ResNet, and wouldn't it increase the latency?
Compared to what, Shreya? So ResNet. So I used ResNet 34. Let's see.
So she's, I think, asking for production environment.
Yes. So So here's the thing. If you're going to try and productionize this, what you need to do is you need to pre-compute all the embeddings, right? So effectively, for the images, you just pre-compute all the embeddings, you store it somewhere, and then it's only the language model part that you will be pushing out for live inference, right? So because the thing is that we have two separate models, even though we train them together. These are two separate models that you can save separately and use in separate things. So, and just to give you another example, at Canva where I work, we're actually using it just the vision encoding part just to do image similarity search. So a user puts a single image and it goes and finds the most similar image to this one. So we're tossing away the text encoder part altogether, and we're using the vision encoder. So yes, if you were to use this entire thing live, yes, it would be difficult, but keep in mind you're only using a single part of it.
Yeah, that makes sense. I think there's a really good question from Nitesh as well. He's also curious about the production environment, and like he's asking how do we quantize the model, and when it comes to putting it on the search environment.
Yes, so this is one thing that we've struggled with, right? So the quantizing, I know that Torch does have a single line where you can just go .quantize model, but unfortunately, it did not work as well as expected. I'm actually banking for something a bit or somewhat simpler. So in PyTorch Lightning, at least, it has a training aware quantization. So I think that would have worked better, because what we did was we trained it first, and once that was all done, then we tried to quantize it. Whereas quantize aware training, it does the quantization while it's training, right? And it adjusts the losses accordingly. So I'm not sure about the specifics inside that, and that's one thing that's great about Lightning, that you don't need to care. But yes, so if we had done that, that would have been a better way of quantizing it. And like you said, for the response time, in ResNet, personally, is actually a decently fast thing. So you don't need to worry too much about response time. We're talking about 100 milliseconds max to pass through a ResNet, right? So it's not too much. But once you get into the transformer-based ones, then it does start getting slow, and that's when you need to care about quantizing. And well, it's not just quantizing, right? So you need to, if you're aware of the having multiple nodes to make sure you serve the model, that's also something that's important. But that's very much on the DevOps side, and I have very little awareness of that side.
Got it. Got it. So there's another question. So Abhishek is asking if there are any other models you have in mind to do categorization for images.
So one of the cool things about this is that the base was something that I randomly picked out, right? So there's no reason that I can't choose one of the efficient nets or the vision transformers or anything else that came out lately, right? So I think that really speaks to the paper as well, that the fact that this is so easy to implement that you can choose anything you want to as a base. And so I don't have any of the models per se in my mind, but you can definitely pick and choose the latest papers that came out. So I know that the latest Resonant, revisiting Resonant's paper, was able to take much less parameters to do the same thing that it used to do, and it's doing better than EfficientNet now. So yeah, if you're looking to productionize, especially, I'll be choosing one of the later models, but with a small amount of parameters.
Got it. So we have another question from Deepak, and he's asking, what are the possible situations when this model will behave poorly, and things that you need to consider to ensure optimal solution?
Right. What would this perform poorly? I mean, obviously, if there are things that it hasn't seen before. Okay, so let me answer in different ways. So if we productionize it so that we just take the top 5 images in our data set, then we might actually run into some trouble, because without a threshold to say we have this much confidence in the image that we're putting out, you should not be putting out, because you might have a complete mismatch between what the person is typing in and the image that you end up putting out. So that's one way that it will perform poorly. But the other obvious thing is that if it hasn't seen something like biological data, right? So if you're looking at cancer cells, which I don't think is in the COCO data set, we will get poor results, because it simply hasn't been trained in that domain. So obviously, the more that you train, the more that it learns, it will get better over time. But I think you do run into the risk of doing that.
And is another question. So this was around. This is probably more of a theoretical question. They're asking that how is Resonant different from other models like CNN, RCNN, or Mask RCNN?
Yeah. So Mask RCNN is doing a different task. So I think you can still use Resonant as a base for that task. So Mask RCNN was to do pixel by pixel image segmentation. Resonant was made to do the 1,000 classification, the 1,000 class classification for ImageNet, right? So I'm fairly confident that people have used Resonant as a base for the image segmentation task. But again, it's Mask RCNN is a model that was done for image segmentation, but using a very specific method, right? So it has anyway, I don't want to go into it because I might answer it wrong.
Yeah,
But the point
this is, I think, this probably is a good question to read more theoretically about. So, okay,
that's right.
so I'm going to wrap this up with 2 more questions. So we have one question from Mono, and he's asking, how is it useful for nanoparticles drug delivery system? That's a
I don't
tricky
think it's a relevant domain, to be honest.
Yeah, I have no idea about this.
Because I don't know anything about nanoparticles, unfortunately. So I don't know. I don't know is the answer for that. I thought there was a question about finance, a financial question. This is gone now.
Let me see. I think
it's a question about. Oh, here we go. I'm wondering what the efficiency of BERT with financial terminology is, or more general applied question and answering.
Oh yeah, yes, that's the next one.
Right. So I actually went to a talk recently, and they were talking very specifically on that same, similar kind of topic. How good is it how good is BERT for finance? Now, it depends on the task, right? So in the case of sentiment classification, to see, hey, they're talking about Apple or Microsoft in a positive or negative way, it does great. It does fantastic. if you're trying to do something else like summarizing financial documents, then not so much. Well, BERT, first of all, can't go beyond 1,000 words, or at least finds it extremely difficult to with the modern compute power. Yeah, so BERT hasn't been trained specifically in the financial domain, but if you're doing something like either sentiment classification or trying to extract amounts from the amount of money that they're talking about in a report, then it might actually do fairly well. But question answering in finance specifically, it might not do well. You do need to train it yourself. There's actually, I know I'm speaking about Hugging Face a lot. There is a very good tutorial on Hugging Face about combining BERT with GPT to do this kind of thing, as long as you have the question and answer data. And so you can go ahead and train it yourself and apply it.
Yeah. And Sachin, like I wanted to specifically mention this, that this is the first time I've ever had somebody have like such an insightful session within 36 minutes. I really appreciate the way you had structured the session, and it was very insightful. Like I typically
Thank you.
see that sometimes people tend to be very explanatory on certain things and not come to the point, but you did a great job on that. So yeah, thank you so much. And I think like we had some really interesting questions, because some of the questions I could have never thought of. So
That's
it
all
was
right.
very
Yeah.
interesting. And thank you so much for being with us. I will, as to the audience, like I'll surely be sharing all the resources which Sachin had presented today, and other of his blogs and the courses that he also mentioned. So all of that will be available on the description below. You can also connect with him on LinkedIn. He's also like very active on posting a lot of articles and like blog posts which he writes. So it'll be great to have him as a connection. So thank you so
Yeah.
much, Sachin. Thank you so
Thank
much. It
you.
was great to have you here. And yeah, I'll let you go. And yeah, we can probably, once you have all the resources, you can send it to me, and I'll add it to the session.
Will do.
Thank you.
All
Have
right.
a good one. Bye.
See you, everyone.